Program 4, and I'm just going to do a bit of a recap on Program 4 for some new faces here I don't think have been to previous meetings. But Program 4 really is very end-user focused, and that's always been the intention of Program 4 to engage deeply with our grower groups where possible, and also the farmers. And we've essentially got 3 key output areas from Program 4 that we're working on. The first one is around the novel plant and systems-based soil management tools. These include management techniques like cover cropping and intercropping, potentially incorporation of organic matter. The second key output area is around novel physico-chemical amelioration options for soil constraints. And here we're really focusing on some of the subsoil constraint issues around sodic soils, some of the issues in some of the sandy soils, for example, that don't hold a lot of nutrient, don't hold a lot of water. And I'm going to give you some great examples there of some of the work that we're doing. And all of that is going to funnel down into our third output, which is around decision support tools. So if a grower has got an issue on their farm, what's going to be the best solution for managing that particular constraint? And we all know that most soils are constrained to some degree or another. There's no such thing in Australia as a perfect soil. They've all got some issues. So what's going to be some of the best management techniques for those constraints? And hopefully there will be some economic components with that as well. So highlights on Program 4, you'll probably see from this, and I'm not going to spend too long on it, that we've got a lot of grower group collaboration. So across our 8 current projects, or 9 current projects, we've got 15 grower groups who are engaging. And some of the projects are actually led by grower groups as well. And when I mentioned this to another CRC, that an end user is actually leading a project, they were aghast, they were horrified. So, all hats off to Michael, the way he set up the governance and the team for the CRC, I think is a great outcome, that we're actually getting end user driven research with the assistance of, our universities and our research partners. That's a great outcome. Another point too is that, the program has had co-investment from GRDC, from Western Australian DPIRD, their Future Carbon Fund, and also some of the Future Drought Fund work. And I've got a slide to introduce that a bit later on. We've got PhD students, but importantly, we've got 16 field trials across the country. And the beauty with some of these field trials is that they're actually helping some other programs as well. We're actually, sending some samples off for other analysis in other programs. So some great outcomes there. What I'm going to do now is I'm just going to flick through a few key projects. I don't have time to go through all of the projects. Last year I took 20 minutes and I only had allocated 10 and I got in trouble, so I promised to keep it a bit shorter this year. But I'm not allowed to use the word poster boy anymore. But there's Terry Rose up in the top right hand corner, who's leading a lot of our work on essentially cropping systems, cover crops, intercrops, even some rotation work. What does that mean for soil carbon, and what does it mean through to soil resilience? Mayran Rashdi is doing a lot of work from Griffith University around soil resilience and what that means. I'm not going to spend any time on that today, but you can look that up on the CRC website. There's some great information there. And look, in a nutshell, I think that work has shown that the temporary intercropping is promoting labile carbon and some of the potentially mineralisable nitrogen. So what that means is that through the season, there's probably going to be more nitrogen made available through soil carbon mineralisation for the crop. We yet to see, I think, some great results on data, but I'll get to that later on. This is a project that Gwen Greelett ran from Landcare New Zealand, and it was a very innovative project. It didn't have a lot of funding, but basically she and her team, and I can't go through all the members there that were associated with that, used a co-design process to, I guess, have a first snapshot look at what some regenerative practices are in Australian systems and what they might be doing to the soil. And some of these sites were systems that have been under regenerative practices for 15 to 20 years, some of them. And while we didn't get a lot of statistically significant data, there were definitely indications in that project that soil carbon was changing, and there were some significant changes to some of those fractions of soil carbon. Again, a bit like what Terry was showing there with his intercropping, there were changes in that that mineralisable carbon, that readily labile hot water extractable carbon fraction that's driving a lot of the microbial processes. And Gwen also saw some changes to some of those nutrient cycling type mechanisms within the system. We're still looking at putting that information up on the website. There's some sensitivities within it, but hopefully in the next 6 months or so, Olivia and the team might actually start getting some information up on the website for that project. Here is a great example of a grower group led project. This is Dave Minke, who's leading 4.1.006, and he's working with 4 other grower groups here, looking at a range of both physico-chemical amelioration, big one being, can we improve sandy soils by bringing up clay and incorporating them, using some novel deep ripping techniques, one being the bedner, for example. On the right hand side there, you'll see a graph. We've got the control and that's yielding, what is that? 3.5 tonnes of grain, and where we've got incorporated compost with the bedner and a bit of gypsum into that system. Now we've got some significant improvements in yield. We've got step change in yield. We're talking 30% changes to productivity in that particular system. And all 4 field sites I think are doing really well, and some of these are continuing in on other projects, some led by Professor Bell. There's been some great results out of South Australia on the Eyre Peninsula. Some wickedly challenging soils, these calcareous soils. We're talking pHs of above 9 in some of these cases, and we have to look at some quite unique agronomic systems and techniques to get step change in yield in those particular systems. New South Wales DPI provided Nigel Wilhelm and Brian Zomer with a unique product, a carbon-based product, and had very, very significant changes in productivity. We can see there the carbon-coated minerals in the middle doing particularly well, and if we look at the stats on the right-hand side, we had an extra 2 tonnes per hectare averaged over a couple of years. So some very significant improvements in yield. And some other management techniques that SARDI were looking at included a high seeding rate, improved use of fungicides, and also banded phosphorus and nitrogen, and they were getting some improvements in productivity there as well. So I think there's some great new concepts coming out around management of calcareous soils, and I'm hoping that project will continue. Murray Hart has taken over on project 42004, and we've only got, I'm only just showing a snapshot of data here, but this is the site at Lockhart, a photo of the site at Lockhart, which I think we're visiting, or some of you are visiting in tour one tomorrow. Thank you, Michael, and getting some really good data from the deep placement of organic amendments. So that was applied with a 3D ripper. The really important point to note here is that don't expect to get immediate advantage. Where you're looking at improving subsoil structure, in particular sodic soils, is not something like fixing up surface pH that you'll get an immediate response or a very, very fast response from lime. It will take years to develop that. And I don't have the photo here, but Shane from the DPI team has got a really nice photo where he breaks open a subsoil ped, and you can actually see the glues, those fungal glues, that are actually starting to develop aggregation at depth. So yeah, some great data coming out of that, and that work I think will continue for a couple more years on a separate project. And we've got some more work here led by Richard and Hassan. So welcome to the team, Hassan. It's great to see you on board. Very, very complex. We've got lots of grower groups here. We've got lots of field sites doing lots of different things, and I think there's some great outcomes there. And I think we're learning a lot about some of the new techniques for managing these sandy soils, getting some quantification around what it all means. And this is a new project. I don't know if it's under my program, Michael. I think it's called 6.4, so program 6, which there is no program leader for. But this was an interesting project in that its end date is actually well beyond the lifespan of the Soil CRC. So that was co-funded or co-invested through the Future Drought Fund. And this project is taking on board 7 of our established field sites, in particular the ones that are really starting to show some advances in soil management techniques. So, hats off to the grower groups involved in those and the team that put that project together. That's a great outcome. Now we're going to get on to some of the modelling work. So we're getting all this information, and there's been some great, I think, negotiations between the team at USQ and others in actually getting data from some of our project teams and some of the grower groups. Accessing data, I think, has been one of the most challenging, even though it sounds simple, I think it's been one of the most challenging tasks for the team at USQ. And this is just one project that Chloe Lai is currently leading, and it's essentially putting together a framework for this data, getting all the data compiled, sanitising it, and starting to understand, for example, does gypsum actually improve yield? So they've got a pretty big meta-analysis underway. And I'm not going to take away any of Suman's thunder, who's going to be one of the PhD students speaking in a moment. And all of this will culminate in our final project, I think, or final major project in Output 3, which is around the development of a next-gen tool. So we're getting all this information put together, and I think this has just been contracted with this project, all this information from our field sites and other field sites around the country that the team can access data from. And we're co-designing the interface of this tool to basically diagnose the soil constraint and what you do with it. And then a part of that work will be taking that tool to the grower groups and going, let's actually use this in a real life scenario. Let's put some test scripts in with what the tool's outputting. How does that compare to what you would recommend or what your agronomists would recommend? So basically, we're going to start road testing some of these outputs from Output 3. Okay, so what I've done, I've got a little bit of a summary of just a snapshot of some of the outputs. I've got to hurry up, sorry. This is my very last slide, Michael. So I had a whole heap of things written down about some of the work, some of the outcomes from cover crops, but my brain's trust on this, aka Terry Rose, said, no, you can't say that. So, okay, how about I say this? No, can't say that. Okay, I'll change it. So I've redacted everything, Terry, and I've said the jury is still out. And but the good thing here is we went to a meeting yesterday with Alice, and there is actually some really, really, really interesting stuff coming out from some of the cover cropping work. And I think we should all be really excited to hear what Alice has to say. Some great outcomes. And Terry's got some good stuff too, but well, I might actually dob Terry into giving us a lecture on cover crops next year, and you can actually fill up 20 minutes with, no, you can't say that. I'm not going to harp on the rest of it. We've got some great data coming through on some of the subsoil amelioration. I think that's where some step change is possible. We've got the data on that. I think we're getting some great handles on management of sandy soils, management of calcareous soils, management of some of these wicked subsoil constraints. And I'm very excited to work with Keith and the team more broadly around some of these outputs for some decision support tools. Thank you. And what I'll do now is ask Alice to come up and tell us all about some of the soil water data. Thank you, Alice.